Okay, this is number 9, and yeah, it's a little tricky here. Sorry, I have a different pen I'm using here, so the handwriting might not be very good, but let's go ahead and take a look at this. So it tells you how high you're initially dropping it from, and then it's going to bounce zero point 0.6 um, of the original height each time. So our equation for this is going to be, let's see, A sub n equals, now the first bounce is not 200 feet. That's where you're dropping it from. So you need 60% of 200 feet, which would be 120 feet. So that's going to be our first term. And then our ratio here is each time it bounces, it's going to get 0.6 back. And then we'll have n minus 1. So it's wanting us to do it an infinite amount of times. So we're going to do, not S of n, S of infinity. There we go. And then we'll have the first term, which is 120 divided by 1 minus r, which in this case will be 1 minus 0.6. So then we end up getting 120 divided by 0.4. And let me pull up my calculator. So let's see, 120 divided by 0.4. And so we get 300. Now, that's not actually our answer here. This one's kind of a tricky question because it asks us what's the total distance the ball travels. And so what happens here is we're going to drop it 200 feet. And so that's a distance it traveled. And so we actually need to include that is part of our answer. So we're going to have to add on 200. But, sorry about that. Let me see. Come on. Okay, go away. There we go. All right. So we're going to have to add on 200, but there's one other thing we have to think about here. So that's the initial, it drops here, and then it bounces up 120 feet, right? That's the initial bounce, right? But then it has to go back down, right? And so really what we're going to have to do is we're going to have to count that 300 there twice, because every time it bounces up, it travels that distance, but then it travels the same distance to come back down. Then it goes up, and it goes down. So the question was a little tricky here. And so actually we're going to have to add another 300 onto that. Did it again. There we go, 300. And so, I'm just running out of room. Okay, so 300, and so when we add that all up right there, we're going to get a grand total of 800. And I apologize for that. There we go, 800. So we had to count the 300 twice that we got from doing the infinite series here, because it goes up, goes down. And then we also needed to add that 200 from the initial dropping height. All right, now let's look at the other one. The other one, kind of similar question, except that we're going to be asking for a finite number of swings in this particular case. So we have the pendulum, and so it's going to go 3 feet at first, and then it's going to go back 70% of the way, and then 70% of that, and then so on, so on, so on, right? And so our equation for that one, let's see, so we're going to have A sub n equals, now we know the initial swing is 3 feet, so that's going to be 3 right here. And then we get 70% going back and forth, basically, so 0.7 raised to n minus 1. Now this one actually will be a little bit more straightforward. We'll just go ahead and use our formula we have for this. So let's see, S sub n equals our first point, and then times 1 minus 0.7 raised to the power of 15, and then all over 1 minus, There we go. Tiny eraser. All right. There we go. Minus 0.7. We'll close that. And let's go ahead and try that in the calculator. All right, so let's see, 3. All right, actually, I'm going to wait on that. I'm going to do the parentheses first. So let's see, 1 minus, oops, 1 minus 0.7. And then let's see, we'll go ahead and raise that to the power of 15, close that, divided by 1 minus 0.7. Oops, need to put that in parentheses. Okay, and so we get that value, and now I need to multiply it by 3. I just did a little out of order. A little bit easier for me with my calculator. I guess it doesn't make that big of a difference. All right, so anyways, when we round that 2 decimal places, we'll get 9.95. All right, hope that helps.